Let us look at search methods in an array. There are two search methods. One is linear search and the second one is binary search. So in this video, we'll look at linear search, and in the next video, we will talk about binary search. So let us look at linear search. Here I have a list of elements. I have taken a list size or array size as 10 and the list size is also 10. Now here I have taken unique elements. So for performing search, the elements must be unique. There should not be any duplicate elements. If there are multiple copies, then if you are searching, we may be getting any one of the copy. May not be able to reach another copy of it. So there should be unique set of elements. Then in a list, if I want to search for any key element, so the value that we are searching, usually we call it as key. So suppose I am searching for a key that is 5. Let us look at linear search method. In linear search, we search for the key in a list linearly by checking the elements one by one. For searching 5, we will start comparing from first element onward. Is it 5? No. Next, go to the next element. Is it 5? No. Go to the next element. Is it 5? No. 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 Yes, it is found here. We already know the element that we are looking for, that is 5, and we want to know where it is present. So we got the index, that is 7. So usually the result of a search is the location where the element is found, so that we can access that element. Now let us take one more key element and search it. So this time I'll take the key element. Key is 12. Let us find out whether 12 is present or not. So we'll follow the same procedure. We'll start from the very first element in the list and compare 12. Is it 12? No. Go to the next element. Is it 12? No. Go to the next element. The next, and even this is not 12, this is not 12, then we have reached the end of a list. So if we have reached the end of a list, means element is not found. If the element is not found, search is unsuccessful. So if the key element is found, we say search is successful. If it is not found, then we say it is unsuccessful. So this is successful. This is unsuccessful. So key element is found, this search was successful. Key element is not found, so this search was unsuccessful. So when you are searching, you have to take care of both the things, whether the element is found or not found. Now let us write a pseudocode for performing linear search. So for searching for a key element, we start comparing the element from the 0th index onwards, and every time we move on to the next element. So it is just like traversing a list. This can be done using for loop, or even if you want, you can use while loop. So I'll first show using for loop. So for I start from index 0. So I should start from index 0, and till where I should go, till the end of a list, and the index is 9. So that is length. Length is 10. So it is length minus 1. So I can say I less than length. So I should traverse the whole length of a list, and every time I should be moving forward. So I plus plus. Then what I have to do? Every time wherever I is, I should check that if the key element is equal to A of I. So if key is equal to A of I, if it is equal, then search is successful. So we got the element. So once you got the element, what we want the index where the element is found. So here we can say return index. So who is giving index? I. So wherever I is present, that is index. Return I. That's all. So let us see how it works. I is initially 0. Suppose the key value that I am looking for is 5. Then it will check I is less than length. Yes. Key, is it equal to A of I? That is key 5. Is it equal to A of 0? 8? No. So it will continue and say I plus plus. I will move to the next index. Then here it checks key, is it equal to A of I? 5, is it equal to A of I? That is A of 1? 9. No. So it will go to the next. So it will continue. And once it reaches here, now this time key is equal to A of I. Yes, 5 is equal to A of 7. Then return 7. So this is in case of successful search. Now what happens in case of unsuccessful search? Let us see. Initially I is 0. Suppose we are searching for 12. First it will check that key is equals to a of 0. 12, is it equal to this one? No. Then I will move to the next element. Then check key is equal to a of 1. A of 1? No. Then again I plus plus, I moves to the next element. Then again check 12, is it equal to a of this? No. So in this way it will continue, and this condition will never be true. So I will move to next, then next, then next, then finally let us take this. I is less than length. Yes, length is 10. And I is 9. Yes, it is less. So key, is it equal to a of I? 12, is it equal to 2? No. Then continue I plus plus. I will move to the next location. Now I became actually 10. This I became 10. And 10 is not less than 10. So it will come out of the loop. So if it is not finding a key element, then it will come out of the loop. If at all key element is found, then it will return, means stop the procedure here itself. So if the key element is not found, then it will come out of the loop. Then outside the loop we can say return. Now if the key element is not found, then we have to return something to show that element is not found. So the invalid index, that is -1. So we can return -1. So usually we do it like this. If the element is not found, then return index is -1. So if you are calling this procedure, then if you got -1 means element is not found. If you got a valid index means element is found. So that's how you can know whether the search was successful or unsuccessful. So this is about linear search. Let us analyze, find out the time complexity of linear search. So one thing I will tell you about time complexity. So for finding the time complexity, either you can observe the work that is done or else you can read the code. So let us see from the procedure. What we are doing for searching, key element, checking, next check, next, next, next. So we are comparing the elements. How many elements we are comparing? At most how many? See, if I am searching for 2, then I may be performing all n comparisons, means depending on the number of elements. Or if I am searching for 8, then I may be getting an element in just one comparison. So if you look at the code now, this loop may repeat up to the end of a list, or if at all the condition is satisfied in the beginning itself, it may terminate. So this loop may repeat minimum for 1 time and maximum for n time. So the best case is that if the element that we are searching is found at first place and the time is order of 1. Best case time is 1. And the worst case is if you are searching for an element which is present at the last index and the time is order of n. So worst case is searching for last element, or the time taken for worst case is order of n. This is case of successful search. What about unsuccessful search? If the key element is not found, then always it will check all the elements, then only it can inform you the element is not there. So for unsuccessful search, time is always order of n. It's maximum time, always maximum time. So unless you have reached the end of the list, you cannot say that the element is not present in the list. So the time taken is order of n. So this was the best case and worst case I have shown you. Now one more thing. Let us look at average case time also. Average case time may not be easy always, so we may not be performing it always because it needs a lot of efforts for doing analysis. So mostly we are dependent on worst case or also best case. Now let us see average case. Let us check. So best case is searching for an element present at 1. Worst case is searching an element present at last. Then these are 2 cases. What are the other cases? Searching for an element present at index 1, that is second element, or the third element, or the fourth element, or the fifth element. So these are all possible cases. Then what is the number of comparisons done for checking if the element is present? Then what is the number of comparisons required if you are searching for first element? Just 1 comparison required. Then what about the element at second location, that is index 1? 2 comparisons required. So the case if you are searching for this, it needs 2 comparisons. In case if you are searching for this, it needs 3 comparisons, so on. Then if you are searching for last element, n comparisons are required. So I have taken the time taken in all possible cases, and I have taken the total time taken in all possible cases. So sum of the times taken in all possible cases. Then total how many cases are there? N elements are there. So n cases are there. So this is n. So sum of the time taken in all possible cases divided by number of cases. This is equal to n into n plus 1 by 2 whole divided by n. N gets cancelled. So this is n plus 1 by 2. So this polynomial is degree 1, that is order of n. So the average case time is order of n. So we have found the average case also. Now, let me say something here. See, usually finding average case time needs a lot of analysis. So you have to consider all possible cases, identify them, take out the time and add their times and divide them by number of cases. This is a little tedious work. And sometimes we may not be able to get some proper solution. So mostly we are dependent on worst case, because usually worst case and the average case will take same amount of time, almost same amount of time. So worst case is easy to analyze. So mostly we do worst case analysis. So this was the analysis of linear search. Now let us see improvement in linear search. Is there any improvement possible? Let us check.